Hi, Lamai. Can you hear me? Can you hear me? Lamai. Hello. Yeah. Come here, Lamai. Hello. Okay. We are going to do very important part. Very important part. So I hope you understood that just bouncing at different speeds. Just bouncing at different speeds. But if the speed is the same, if the speed factor is the same, the thing is going to be changed. So now write change of momentum. Change of momentum. Change of momentum due to bounce back. Change of momentum due to bounce back of an object equals to the magnitude equals to the magnitude equals to the magnitude of initial velocity equals to the magnitude of initial velocity in the opposite direction. In the opposite direction. Let's see how does it happen. How does it take place? The same mechanism. Now you can do it. ඕක හිතලා කරන්න බැරි නැති වැඩකුත් නැහැ. හැමෝටම හිතන්නත් බැහැනේ. ඉතින් අපි යාලටත් සපෝට් එකක් දෙන්න ඕන. Those who can understand this quickly, get your answer for yourself. This is Pi, this is Pf. I want to find out delta P. But it is not U and P. It is going to be like U, and this one is also U. Now try. Try එකක් දාන්න බලන්න. ඔය දෙන්නේ one shot කිව්වා. Madhurukshan, very good boy. Others එක shot එකකින් කිව්වා. මට කිව්වා. No way, no way. No way, boy. Others? No way, boy. Haridari Savindra, very good. Very good. But you can do some mathematical arrangement in the products. You can put constants, numbers, and certain symbols at anywhere. So if you think that again and giving priority for the numbers, you should rewrite in against different way. So most of them arrive at the answer. So I will write the answer. Yeah. Delta P equals to Pf minus Pi. Yes, indeed. So let's try to find out what is Pif. As usual, I give the priority for the final direction. So mu is the final direction. Initially, it is moving in again mu, but negative because this is to here, here, and that to there. So to bring them to the same direction, so I have to change the arrow. So it is going to be like delta mu plus mu 2mu මදුරුක්ෂන් එක තප්පරෙන් කිව්වා. I need more Madrukshans, more Savindra Devs in this class. Mr. Madhuru, you have a really good improvement. Others, I also expect the same thing, like how Madrukshan do, how Savindra do, how Opesani do, how Senithma do, how Sehanti do, but Sehanti only remaining for 40 minutes and she just go. I don't know why. හැමදාම විනාඩි 40ක් විතර ඉන්නවා දුවනවා. So Lasmi Amshi battery පොඩ්ඩක් බහැලා. එන්නගේ battery පොඩ්ඩක් බහැලා. Okay, guys. Okay. Now it is going to be the challenge. Now it is going to be the challenge. බලමු challenge එක මොකක්ද කියලා. I am going to erase this. Now write change of momentum. Write this change of momentum due to what? Collisions occur at an angle to the normal of the surface. It is like O level. In O level you learn something like this, no? In law of reflection. So in angle of incident is equals to angle of reflection. Can you remember O level? Your O level diagrams. Angle of incident is equals to angle of reflection. It is something like this. The angle can be vary here, but still I got the same angle. I am considering this like U. This is again I consider like U for my convenience. දෙකක් වෙන්න පුළුවන් අවුලක් නැහැ. But here I consider it like U, same velocity. This is the final momentum. This is the initial momentum. Okay. I need an answer for delta P. Now you have to consider two different things. One is the change of vertical momentum. Horizontal momentum. Other one is change of vertical momentum along the plane. දෙකක් තියෙනවා. තේරෙනවනේ? This carries momentum in 2D, no? See? One is to here. See? You can resolve this momentum into the wall and along the wall like this. So get use of your vectors knowledge and find out the momentum horizontal, that means perpendicular, or you can write it like perpendicular. Other one is along plane. ඔන්න ඔය දෙක විනාඩි දෙකක් තරම් හදන්න. Try these things by taking your time a bit. Try this. Fatima? Fatima? Can you hear me? Fatima? Yeah. Is this lesson hard for you? Amaru මේක ලේසිද? හරිම complicated. No. Not means hard. Okay. Easy. Can understand. By the way, how did you get to know me? How did you get to know of me? The source of information you got about my class? From Sandeep sir. Okay, very good. Okay, by the way, try this. Along vertical and the horizontal. Okay. Madhuruksan, could you come up with an answer for the vertical one? Because remember, vector is momentum is a vector. Always have to specifically consider about the direction. Perpendicular and along. Did you get an answer for the perpendicular part? Yes or no? Savindra, very good boy. Savindra boy, very good. Yeah, man. What is that answer, man? Madhuruksan, that answer is really very weird one. දැන් වෙක්ටර් සමත කරලා තියෙන කට්ටියට තරු පේනවා ඇති S2 වට එහෙම තරු කරගෙන. තරු කරගෙන. No. Your correct final answer is correct. Your final answer is correct. I'm telling that Madhuruksan's one is a very weird one. Oh, Senethma very good, but Senethma also wrong. Senethma is very good. Senethma is wrong. That means your one answer is very good. One answer is very bad. It is a vector, so have to consider directions. You are a very bad girl. You couldn't think of that direction. I'm repeatedly telling you, she's the only one sent me both answers and she tried very good. I only asked the vertical, but she sent the horizontal, so vertical always. Okay, now I am going to try in whose way? Mr. J's way. Have you seen this gesture by someone? Boys, haven't you seen this gesture? Guys, very innocent boys. Mr. J, this is Mr. T. Mr. T is going to do this. Okay, have a good look at it. So I can resolve this in this way. This is like u cos theta. Along here, u sin theta. See? Now when you extend it, it gets u cos theta to collision point. So here, see, when you resolve u cos theta, along here u sin theta. Sin theta. At this collision point, it again imparts, see, u cos theta and along here u sine theta. From this one, the motion of against here, this motion gives u sine theta. This motion also gives u sine theta to this point. Now I am going to consider perpendicular here, this. I am going to consider this as the positive one and this as the negative one. P final minus P initial. Okay, delta P is equals to, here in this direction, mu cos theta minus mu cos theta. So you can finally write the answer like 2 mu cos theta. Mecharai. Nothing else. Savindra Dev, your answer is correct. And Senithma, your answer was correct. Mega Therin Nati Babala in other. Is there any baby that you can't understand this one? Babies, I'm talking to you. Hi, babies. Hello. තේරෙන්නේ නැති කවුරු හරි ඉන්නවා නම් ටක් ගාලා මෙසේජ් එකක් දාන්න කියලා දෙන්නම්. I am here to explain you everything, but you have to ask me. Is there or not? Yeah. Yeah, sir තමයි. Fine. Yeah. Sir. So you said, sir, I'm waiting. Only 10 seconds more. Okay, when considering the direction of balls. What else? Tell me. It is mu, yes. So ඔයාගේ ප්‍රශ්නේ ගිල ගිල අහන්නේ මම වැඩි වෙලා බලන්නේ නැහැ. Only 10 seconds for you. Just speak up, man. ඔල්ලෙක් නේ කතා කරලා අහන්න. MG cos theta. See. Finally, you. Where is MG? MU. There is no G here. You are considering about that as a projectile. නෑ. මේක හිතන්නකෝ එයා මොලිකියුල් එකක් වගේ දෙයක්. Yeah, mu. There is no MG here. There is no mu. It's always. I only consider the change of velocity here to find out. So change of I only apply the velocity. So mass is a constant thing. No? I didn't try to put change of mass because mass is not changing, only the velocity changing. So I can get the answer into any form after that. That's why I didn't do that. You are thinking only like he's only applying U. Yeah, actually MU, because I didn't bother about applying M here. Because M is not changing. There no other. Only I have put U. Because I only considered about changing factor here. That
So
might
no,
be
sir. I'm asking, sir, if the ball is hitting the surface in angle, sir. So then that ball has the moment of mu no, sir, first.
Yeah. Then.
So it's the initial velocity of it. So
no,
after
you have to consider both together, M and U together. But I only considered the change of velocity and show you how velocity changes.
Okay, sir. Then
the momentum, to get the momentum, you have to multiply change of momentum, sorry, velocity into mass to get the momentum. No?
Okay, sir. Then
So
why you considering?
I only considered the change of velocity.
Okay.
And you can just multiply that by the mass and get the final answer. Don't you understand it?
So, I didn't understand why you are considering that mu cos theta, sir. Perpendicularly.
Okay. I can apply m, and mu. Are you happy?
No, sir, I'm asking why that cos theta, sir. We are considering that cos theta.
Perpendicular.
So, but the ball travels within an angle, no, sir, not perpendicularly.
That's why I asked you two questions. One is perpendicular to the plane. Other one is along the plane. I asked two questions. One is perpendicular to the plane. So it doesn't hit perpendicular, no, it is hitting with mu here. See, but with an angle, the perpendicular component is only the u cos theta. Don't you understand?
Okay, so then we will consider the perpendicular reaction force.
Yeah, perpendicular to the component for the velocity. So the momentum factor also, what? P cos theta. Understand?
Okay.
So momentum is not 100% transferred to here. P cos theta. Now again, there is a factor along the plane also applying. That is what? P sin theta. Power ගිහිල්ලා බිත්තිය හැප්පෙනවම තනියෙන්. If you collide against a wall like this, you will get hurt a lot. But if you hit like this way, you won't hurt like that much. Why? The collision is not perpendicular. It is like sliding thing. Understand? වැදිලා
Okay.
නැද්ද කවදාවත්? තනි ගෙලිනුයි මෙහෙම සයිඩ් එකෙනුයි. As a boy, when you're running, haven't you ever got hit against like a certain wooden branch or like a light post or something directly? Then you get hurt a lot. But when you hit yourself sideways, it is not perpendicular, it is sliding like this way. That's why I try to show you. It is a motion like this. See, bouncing off like this. See? Can you understand? Hit and move. Hit and not. It is not like hitting like this and bounce back perpendicular. It is certain instant hit with an angle, bounce off with the same angle. Don't you understand?
Okay.
Others? I'm really happy Madhuksan spoke and asked his all the doubts. Others, do you have any doubt? Understood. Okay. Now I'm going to explain you along the plane. Along the plane here, initially mu sin theta. This is the initial thing. In the final way, again mu sin theta. This is the final one. Now I am going to subtract these two to get the final one. Delta P in that direction, what? Along the plane, mu sin theta minus mu sin theta. What is my answer? It is 0. Final is 0. Other Senet mage otana thamma වැරදුනේ. Okay? Understood? See, put like 2 mu sin theta. It is in the same direction. Mu sin theta minus mu sin theta means 0, not 2 mu sin theta. Understood now? Very good girl. Madhurukshan, is that doubt clear?
Okay, sir. Doubts. Yes.
Doubts තියෙනවා නම්, if you have any doubt, just ask me. I'm here to explain you everything. Ask me. Nani? Idea again. Copy everything. How many days? Come on, leave කරන්න. Sorry. Take a screenshot. I want to leave to my usual what? Share board to do questions. අපි යන්න share board එකට. කියන්න. Shall we move on to our usual share board? කවුරුහරි කතා කරලා කියන්න වහා කියලා. I would like to hear a voice. අයියෝ ලැජ්ජයිනේ. හරි, let's move to the share board. Hi guys. I hope you are hearing me. Now whenever you text to this device, okay, I'm sending a random message that appears to be like think is my other one. Text to that one. So okay, give me a 1 minute. I'm going to import the file. Wait. Give me a 1 second. I made a terrible cardinal sin here. Lamai, give me a 1 minute. Okay, I got that tute here. Right. So I hope everybody got this tute, theory tute. Did you get theory tute, everybody? Did everybody get the theory tute? Ramai, did everybody get the theory tute? Hello? I don't hear you. I don't hear you guys. Yeah.
So there are all the theory you want. So, and there are some kind of hard theory. But that theory is called as law of conservation of momentum and collisions in 2 dimensions. So this is the one thing we are going to learn in the next week. Okay, this part we are going to learn in the next week. Don't be really hurry to learn that part. And the impulse and everything we are going to learn in the next week. So for until so far, the theory what we learned is really important to understand, like the change of momentum. So you may try to read. That's really important. If you can read this one and collision in 1 dimension and try to understand. I'm pretty sure, like, if you try, only like 10% of the students can understand by reading this thing. But I'd really appreciate if you can read and try. But most of the time, you might not get succeeded. Especially this part, you will understand after we do law of conservation of energy. It's a future lesson. But you'd better read. I'm 1000% sure you won't understand alone. So you'd better read and get to know these terms like impulse, linear momentum, and moment force, external force, elastic collisions, inelastic collisions. Now, but after collisions, we can't calculate any of this so far. No. Okay, give me a 1 second. We may try this question number 1 and question number 2. Don't try the question number 2. It is a conservation of momentum. We haven't learned, but we can try the first one. That's in the page number 10. I can hurriedly teach you if you want the law of conservation of momentum. But that is going to be really chaotic. The whole prasnayak way. So better to learn that in the next week. We are not in a hurry now. Okay. Shall we try this? I will give you a time of 4 minutes. That's more than enough. Even 1 minute before the class to finish, I am supposed to explain this. Let's see. A rugby forward of mass 120 kilogram storms forward with touchline with 6 ms minus 1. Calculate the magnitude of momentum. M equals to 120 and he's moving with 6 ms minus 1 as the velocity. So you can just use like V equals to mv. M is like 120 multiplied by 6. You will get like 720 kg ms minus 1. Right, very good. Now the second thing is, at what speed would the rugby fly half of mass 72 kilogram have the same momentum as the storming forward in A? Another player, he will have to run faster because he's lower weight, like my weight, just like 8 kilograms lower than me, but still not as heavy as the previous guy. Okay, now have a good look at P is equals to mv for that guy even. So this is the P we know, 720, and the mass is 72 multiplied by velocity, that is the factor I don't know. V is going to be 720 divided by 72. So the velocity is 10 meters per second. Understood? Okay, very good. Quickly copy this thing. Right. Let me move on to another calculation because this is a collision. For the collisions, we can't do without knowing law of conservation of momentum. Right. The third one we can do, we can try the question number 3 that is in on the top of the page number 11. Try this. Four minutes again.